Okay, so Unit 4, Systems of Linear Equations. System of linear equations has at least two equations with at least two variables. Okay. Now, first one we're going to solve by substitution. The objective in substitution is to find a variable that you can get by itself. In this case, it's very obvious I can get y by itself here. I only have to subtract 4x from both sides. So now I have that y is equal to 24 minus 4x, or negative 4x plus 24, doesn't matter. It'll all sort itself out in the end. Then you recognize that this y in this equation here is the same as this y in this equation here. So you have 2x minus 3, but instead of y, I'm going to leave myself a space, equals negative 2. Instead of y, I'm going to put this value in for y. So 24 minus 4x. Now that I have it written as such, I now have one equation with one unknown, which I can solve. So, you do the distribution. So you have now 2x minus 72 plus 12x is equal to negative 2. You combine your like terms, so you have 14x minus 72 is equal to negative 2. You add 72 to both sides, and so you have that 14x is equal to 70, and then you divide both sides by 14. And so you have that x is equal to 5. Once you have your x value, you're not done. You need to solve for the y value. So you plug this 5 into this x. So you have y is equal to 24 minus 4, but instead of x, you're going to put 5. So you have y is equal to 24 minus 20, which is simply 4. Your final solution should be stated as a point, as an ordered pair, 5, 4. Well, that was fun. The second is like unto it. Here we can simply rewrite this as y is equal to 5x plus 12. Instead of writing 4y plus 16 is equal to 20x, you say 4 times 5x plus 12, that's your y value, plus 16 is equal to 20x. Once again, you have two equations, two unknowns. You distribute, you have 20x plus 48 plus 16 is equal to 20x. Well, then you combine your like terms further. 58 plus 6, 64, 20x plus 64 is equal to 20x. Well, this is going to be fun in the end. I'll show you why. When you subtract 20x from both sides, variables cancel on both sides of the equation to 0. This leaves you with 64 is equal to 0. That is not a true statement. So we've arrived at a contradiction, which indicates that we have no solution. If you arrive at a contradiction, you have no solution. If you arrive at a tautology, the solution set is infinite. Solve the following systems by elimination. Elimination is actually pretty fun, and in this case pretty easy. Elimination, you want to use the equation in one variable to eliminate the equation in another. And so what you want to do is, it would be great if these two x's could cancel, but they don't have the same sign. So what you're going to do is you're going to make one of them have the same sign. In this case, we are going to multiply both sides by negative 1. So your new variation is going to be negative x plus 2y is equal to 9. Did not change the first equation. X plus 3y equals 16. And then you simply add down. Well, x minus x is 0, so I don't have to worry about that. 2y plus 3y is equal to 5y, and 9 plus 16 is 25. To get y by itself, you divide, and y is equal to 5. Once I have a y value, I can then replace this y with 5, and so I have x plus 3 times 5 is equal to 16, x plus 15 is equal to 16, and x is equal to 1. So, 1, 5, final solution. Okay, next one. Little bit uglier, not much. In order for elimination to happen, both equations have to be in standard form. In this case, neither one of them is, which is very upsetting to me. Oh well. So I'm going to clean this up as a negative 4x minus 5y is equal to negative 9. What I did was I subtracted 5y over here, and then I used my reflexive property. Next one, I decided, okay, negative 11x minus 9y is equal to negative 20. Actually, neither one of these is pretty as a standard form equation, and neither one of these is factors of one another, but that's all right. Least common multiple of 4 and 11 is 44. Least common multiple of 5 and 9 is 45. Say we go for the one that requires less work. Okay, so I'm deciding I'm going to eliminate my x's, which is something I've been meaning to do for a while. So what I'm going to do is I'm going to multiply this coefficient here by the coefficient of the other value of x. So I'm going to multiply everything here by negative 11 and by negative 11. Now, there's a reason I'm multiplying by the coefficient of the other. One, I have to precipitate a sign change. Now, I'm going to multiply all these ones by 4 and by 4. So you have negative 44x plus 55y is equal to 99. Here you have this one's positive 44, sorry. Here you have negative 44x minus 36y is equal to negative 80. Now we add down, these cancel to 0, and this should be 19. Yes. 19y is equal to 19. Y is equal to 1. Take the y value, plug it into either equation. I like the first one at the beginning. Negative 9 plus 5 times 1 equals negative 4x. Negative 9 plus 5 is equal to negative 4x. Well, we just found that negative 4 is equal to negative 4x, and that x, trivially enough, is equal to 1. So your final solution is 1, 1. Which was a whole lot of work for a very simple solution, which in some ways is kind of insulting. Okay, matrices is actually pretty simple and fun. Now, easy way to do matrices is on the calculator. We're not doing Gaussian row reduction by hand, although it's great fun. I'm still working on the 10-dimensional matrix for one of my Algebra 3 kids he wants to do just to show that he can. But anyway. First, you're going to construct the matrix. A matrix is basically an array of the coefficients and the constants of the system. So, your matrix conversion of the system is 7, 5, 3, coefficient, coefficient, constant, 3, negative 2, 22. So we're going to plug that into our calculator. We're going to put it in what's called reduced row echelon form. Let me write that down. Reduced row echelon, fancy French word, echelon form. Gotta love it. In a calculator it is, well, I'll show you in the calculator in a moment. So the first thing you're going to do, I'm actually going to write the commands out for you since there's not much work to be shown. You select second, matrix, edit. Second, matrix, edit. We're going to edit matrix A. And you input the dimensions of a matrix. Now, a matrix is divided into rows and columns. These are rows. These are columns. So in this case, we have 2 rows, 3 columns. So now we're going to punch our values in. So 7, 5, 3, 3, -2, 22. You have to hit enter after you've entered each element. So now let's go to second quit. Have to quit out, otherwise the last element will not be saved. Now, then you go second matrix math. Now, there are a whole lot of commands going on in the math menu for the matrices. Only one of them is useful. You are not looking for the determinant, you're not doing a t-test, you're not very dim, you're not filling it, you're not having an identity crisis. Yes, I am very random, but this is not it. We're not augmenting. We are not doing a matrix list. We are not listing the matrix. We are not finding the cumulative sum. Gentlemen, don't get too impressed by that command. We are not refereeing. We are looking for reduced row echelon form. Notice how it is RREF. So we're looking for the reduced row echelon form of the matrix we just entered. So we go back to the list. And then we hit enter. And there we go. And so now we have the matrix in reduced row echelon form. You have 1, 0, 4, 0, 1, -5, which is to say that x is equal to 4 and y is equal to -5. So your final solution is 4, -5. Same basic idea happens here. Your coefficient is 4. Here I don't see a coefficient, but what's the coefficient I don't see? 1. Constant is 2. Here we have 1, -1, and 3. So once again, we're going to have a 2 by 3 matrix. We may as well just edit the one we've got. And so the dimensions are the same. We just go 4, 1, 2, 1, -1, and 3. After that, second quit. Go back to your matrix menu. It's actually quicker to get to RREF by scrolling up instead of down. Once again, we're applying it to matrix A. And here we have our reduced row echelon form matrix, which is as follows. And so our solution set is 1, -2. So that was fun. Okay. This one, you are solving the system by graphing. You will notice that neither one of these is in slope-intercept form. You have 2 choices. You can either put it in slope-intercept form, or you can graph it from standard form. Me, I like graphing from standard form, but not all of you are the same type of masochist that I am. So let's get y by itself. We have -y is greater than or equal to -2x minus 3. And then you divide by -1 to get y by itself. Y is less than or equal to 2x plus 3. Because when you multiply or divide by a negative number, the direction of the inequality switches. So you now have 2x plus 3. You start at 3. And you're going up 2 and over 1. So once you have that, it's a solid line and we're shading below. Now don't do your shading until you get both inequalities on the map, otherwise you will totally screw this up. So that's the first one, and suffice it to say we know we're going down, so I'm just going to give myself a little arrow so I know which way I'm going. Next one, want to get y by itself. Okay, we've got 2y less than negative 4x plus 6. We just subtracted 4x from both sides. Divide everything by 2. Negative 4 over 2 is just negative 2x plus 3. So here again we start at 3. We're going down 2 over 1, down 2 over 1. Now in this case this one's going to be dotted, right? So, got down 2 over 1. Now the system of inequalities, you're looking for where the two shades come together. So, you're looking for where this one goes down and this one goes down, so you look at where they go down together. So, this one is going down this way, right? This one's going down from here. So the places where they come down together, where they kind of cross, that's going to be your solution region or solution space. It's not going to be a solution point. Okay. So let's take a look at these last two. Layman selling tickets, first day of sales, faculty sold 4 faculty tickets and 5 student tickets, so that would be 4F and 5S equals 102. Day 2, 7F plus 5S is equal to 126. Right? In this case, I'm going to just say that F is, and so it's asking for S, but that's okay. We can solve this by elimination. Since these are the same, we can actually eliminate by subtracting the first equation from the second. Okay, so I'm going to go ahead and make this all negative by distributing -1. So now I have 3F is equal to 24. So F is equal to 8. Now, I have a value for F, now I'm going to solve for S. So, I'm going to use my first equation. 4 times 8 plus 5 times S is equal to 102. 32 plus 5S is equal to 102. 5S is equal to 70. S is equal to 14. Subtracted 32 from both sides, got 70 divided by 5. That was fun. Okay, next one. Perimeter of a right triangle is 30. One of its legs measures 5 centimeters. The other leg is... Find the other leg and the hypotenuse. That one might be fun. X plus Y plus 5 is equal to 30. I'm thinking that there's a piece of information missing on this one, because oh no, it isn't. It's a right triangle, so we get to use the Pythagorean theorem. Got it. Alright, so let's go on ahead and define which one's the other leg and which one's the hypotenuse. So, x squared is going to be the other leg, plus 5 squared equals y squared. So that's fun. So, let's do a bit of substitution, shall we? This one's actually going to be a fun little quadratic. This one took some doing. I decided to let x be my leg. So that's why it's x squared plus 5 squared equals y squared. So, I'm going to get y by itself. So y is equal to, I'm going to subtract 5 from both sides, 25 minus x. Okay, so now x squared plus 5 squared is going to equal to 25 minus x quantity squared. So in other words, I took this value for y, plugged it in here. This is going to be exquisite. But x squared plus 25 equals 625 minus x squared. Always fun. Now, gonna move all my stuff to one side, and so I have x squared. It's actually going to be two of them. 2x squared, because what I'm going to do, there's not exactly enough space to show this, but that's right. X squared, we're going to add that, and then we're going to subtract 600. Or, sorry, subtract 625. So we have 2x squared, sort of box that up over here. 2x squared minus 600 is equal to 0. X squared minus 300 is equal to 0. X squared is therefore equal to 300, and x is therefore the square root of 300. Now that I have a value for x, I'm going to plug this value back into here. So the square root of 300 squared is just 300, plus 5 squared is 325. So I now have that y squared is equal to 325, and y is the square root of 325. I'm leaving it as such because I really don't want to get into ugly decimals, and I do not actually recall one of these ugly Pythagorean theorems coming your way for the systems. So that was fun. We'll get to quadratics, functions, equations, and inequalities next.